We're going to look at matrix solutions to linear systems today. This is actually a very simple thing to do because it simply involves addition, subtraction, multiplication, and division, but the steps can be very long and drawn out, so I encourage you to really pay attention to what we're doing. Matrix solutions are very good to use. They're really practical in computer programming, and they're really more practical when you're dealing with more than two variables. When you got 3, 4, 5 variables, matrices, it makes things a lot easier to work with. Well, the first things we're going to do is take our systems of linear equations. In this case, I have 3 equations and 3 variables, and that's your basic rule of thumb. If however many unknowns you have, that's the minimum number of equations you need. And I'm going to take all my coefficients, this 3 for the x, the 1 for the y, and the 4 for the z. I'm going to start building my matrix. On this left-hand side of the matrix go all my coefficients. 3, 1, 4, 1, 1, 3, 1, 3, 2. Go on the left-hand side. Then I have this bar. This is called an augmented matrix because what I'm doing is I'm adding it, I'm augmenting a side to it, and I'm putting all the solutions on the right-hand side. Now, my goal in all of this is to get a identity matrix over here. I want zeros everywhere except on the diagonals. I want 1, 1, 1 on my diagonals, and then zeros here, 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 and there. Okay? Now, one of the nice things about matrices is that they give you a great deal of flexibility. Now, I notice my second equation is 1, 1, 3. I already have a 1 and a 1 in the x and the y value. So what I'm going to do is I'm going to move that up to my top row. Now, this doesn't matter because you are basically given 3 equations. It doesn't matter which equation comes first. So I'm moving it to my top row. Life gets a little bit easier, okay? Now, remember my goal is to get 1s in my diagonals, and I'm trying to get zeros everywhere else. So we're going to start doing what we call row operations, where I'm going to start combining rows and then replacing them, okay? Now, your first goal is to look at the x's and get these bottom 2 rows, these x placeholders, to be 0. So let's do this bottom row first here, okay? Notice I have a 1 here in this first row and a 1 here in this bottom row, and I'm going to use the first row, this x placeholder, to kind of dictate how I get rid of these other 2. So I'm going to use this. I have a 1 and a 1. They're the same. So I notice if I subtract 1 from 1, I get 0. So that's basically going to give me my equation. I'm going to take this first row and subtract this third row from it. My coefficients here are 1 and 1. So I start with my original matrix here. Then I'm going to take the first row and subtract the third row. So the 1 minus 1 is 0. That's going to replace my new third row. 1 minus 3 is negative 2. That's the new value in this part of the third row. 3 minus 2 is 1. And 12 minus 13 is negative 1. Now I've adjusted, I've changed this bottom row, and I have a 0 in this placeholder, which is what I want. Let's do the same thing for the second row. I want a 0 here in place of the 3. So again, I'm going to use this 1 to key my decision. The 1 and the 3, the least common multiple is 3. So I'm going to multiply my top row by 3 and subtract my second row. So 3 times 1 minus 3. Again, I start here with my matrix, my new one. 3 times 1 is 3, minus 3 is 0. Same rule. 3 times 1 is 3, minus 1 is 2. 3 times 3 is 9, minus 4 is 5. 3 times 12 is 36, minus 17 is 19. So what I've done now is I have a new matrix, okay, that has a zeros in these bottom 2 rows for the x placeholders, and because I rearrange things, I have a 1 in my top row. So I am now well on my way to getting a identity matrix with zeros everywhere except on the diagonal. Now, where do I go next? The way it works is you handle the bottom set of zeros first. So I handle the zeros here and here. The only other 0 left on the bottom is right here. It's in the bottom center of the it's in the center of the bottom row. So instead of this top one, okay, I don't want to mess with these zeros anymore. So I'm going to use the second row now to kind of key what I want to do, because this 0 here isn't going to affect anything down here. So I'm going to look at this 2 and this negative 2. I notice they're opposites. So I simply add them they're going to add up to 0. So my new equation is R2 plus R3, row 2 plus row 3. Well, 0 plus 0 is still 0, so nothing changes. 2 plus negative 2 is 0, so I'm going to replace this bottom row with 0. 5 plus 1 is 6, and 19 plus negative 1 is 18. So now, notice what I have down here. I have all zeros on this bottom left-hand portion of my matrix. Now, remember, part of it was getting zeros, part of it was getting ones. Well, now that I have zeros on everything except for this z entry, I'm going to take this part here, skip down here, and I'm going to try to make this 1. Well, addition and subtraction won't work here. We simply need to do division. I'm going to simply take row 3 and divide everything by 6. Well, 0 divided by 6 is still 0. Same here. 6 divided by 6 is 1, and 18 divided by 6 is 3. So now I have zeros in the bottom part of my diagonal, and I have a 1 right here, so I am doing great. Now I have zeros down here. Now it's time to turn my attention out to the upper right hand part and get zeros up top. We're going to do the same thing, but we're going to key on this third row now. What's really nice about this third row is I have zeros over here for the x and the y placeholders. So I'm not going to affect anything above it. So all I have is the z to worry about. So I'm going to take this row 2. I have a 5 and a 1, the least common multiple is 5. So I'm going to take row 2 and subtract row 3 from it. Now I keep saying I'm going to take one row and subtract the other. The idea is you're going to take one row, add or subtract a multiple of the other, and then figure out what row to replace. I'm trying to make this a 0 here. So this is going to be my row I'm going to replace. So 5 minus 5 times 1 is 0. And 4 minus 5 times 3, which is 15. So 19 minus 5 times 3 is 4. So notice I didn't worry about these top two spots here because I had zeros underneath. So row 2 minus 5 times 0 is still whatever the original part of row 2 was. Now I have a 0 here in the z placeholder of row 2. I want to do the same thing for the z placeholder of row 1. I come back here. I have row 1. I have a 3 in the z placeholder and a 1 down here. So I'm going to take row 1 minus 3 times row 3. So 3 minus 1 times 3 is 0, and 12 minus 3 times 3 is 3. Again, I don't worry about up here because I'm not changing anything down here. This being a 1 makes life real easy. Okay? Now I'm getting very close. I got zeros here. I got this little 2 here, so let's do the same thing we did before. We want to get 1s in our diagonal. So I am going to take this entire second row. I'm going to divide it by 2. That gets rid of this 2, and now I have a 1 here and a 2 here. Now I'm just at the very end. I had to get rid of this little 1 up here. Well, by now you should start seeing the patterns. The only one I want to worry about is row 2 and row 1. I'm back at my equation. I'm going to take row 1 minus row 2, and I'm going to replace it into row 1. So 1 minus 0 is 1. 1 minus 1 is 0. 0 minus 0 is 0. And 3 minus 2 is 1. So now I have this identity over here. Bunch of zeros on the bottom, bunch of zeros on the top, and 1's down the diagonal. What the heck does that mean? Well, this basically, if you go back up to your equations and how we set this up, this was the coefficient of the x, the coefficient of the y, the coefficient of the z, and the constant. Well, my y and z are 0 here, so my equation is simply x equals 1. This equation becomes y equals 2, and this equation becomes z equals 3. So my solution set is the point x, y, z is the point 1, 2, 3. This is going to take a lot of practice. Don't get frustrated with it. Hang in there. Good luck.